One of the most requested videos of today was the do first, which kind of takes us back to chapter 1 and chapter 2, where we are moving functions around. So to show two equations, what parent functions do you see in the system? So I circled f and g for you just to kind of draw your eye to that. And you can see the function f here is in a v shape. The v shape is always absolute value. And so it's going to look like this. The parent function will go through 0, 0. Each of these lines, slope of 1, slope of -1. And the parent function is y equals absolute value of x. This is absolute value, and we called that f of x in this one. So for the g of x function here, the g of x function is just your straight linear function like this is the parent function. This is y equals x. This is linear, and they call this one g of x in this one. Okay, so those are the parent functions that we see in the system, and we need to talk about what transformations happen to make this image appear. So again, you notice that every one of my parent functions here is going through the origin, so I'm going to dot that in, and then I also want to dot in the vertex, so I can see, okay, this has been shifted over, f of x has been shifted over 1, 2, 3 units, so that is x minus 3. Again, when we're operating inside of the grouping, you're going to use the opposite sign. So here, my pencil is at +3, so I need to use a -3. And then we're going to go up 1 unit, so that is +1. The reason why I put the 3 inside of the grouping is because moving left and right is a horizontal movement, and the horizontal axis is x. So I need to match up my 3 with the x grouping. It goes inside of the x grouping. And then if I'm going to move up and down, that is the vertical movement, that is the y-axis. And so I cannot go inside of my grouping for that. I need to note it on the outside. Okay? So there's my equation for that. And then if we wanted to solve for y equals mx plus b, in other words, this straight line, we'd have to think about y equals mx plus b. What is the slope of this line? And the slope here is 0. In other words, if I were climbing this mountain, it's just flat ground. So if I were climbing this mountain, it'd have a difficulty of 0. It's flat ground. So y equals 0 times x, and then plus b. Your b value is just where the line crosses the y-axis, the y-intercept. Your b value is 3. So y equals 0x plus 3. Let's do some simplifying. 0 times 1 is 0. 0 times 2 is 0. 0 times x is just 0. So all of this simplifies down to 0 times x equals 0. So y equals 3 is all we're left with. And those are my two equations. I have y equals the absolute value of x minus 3 plus 1, and I have y equals 3. In part D, they asked me to actually just set these two equations equal to one another. So I have y equals y, and through absolute value of x minus 3 plus 1 equals 3. These are the same, so we're going to cancel those out, and you're just left with the absolute value of x minus 3 plus 1 equals 3. So to be able to translate this into one solution for x, what we want to do is solve out by subtracting 1 from both sides. To get us started, we'll have the absolute value of x minus 3 equals 2. Now, when you look at your absolute value function, you can notice that it's going off in two different directions. So, in other words, it's going to have two solutions. Another way to think about that. If it's got two solutions, what you need to do is take this 2, and you're going to have one that is positive 2 and one that is negative 2. A good way to think about this is the absolute value of negative 2 is positive 2. The absolute value of positive 2 is positive 2. So both of these ways will get us to positive 2. So we're going to use both solutions. And you've got x minus 3 to bring down and x minus 3 to bring down. So if you add 3 to both sides, x, and then minus 3 plus 3 is 0, and then 2 plus 3 is 5, so x equals 5. Let's look over here. We have negative 3 and positive 3 is 0, and we have negative 2 and positive 3. This is x equals 1. And the good news about our two solutions here with the equal sign is that the next question asks us to use a different type of sign. Instead of using the equal sign, we're going to use the less than symbol. And then we'll solve out basically the exact same way here. So the next problem, again, it says f of x is less than g of x. So in this one, it was f of x equals g of x. So we're going to set it up. Absolute value of x minus 3 plus 1 is less than 3. We're going to subtract 1 from both sides. This is basically the exact same thing that we did last time. We have absolute value of x minus 3 less than 3, less than 2. And then what you're going to do is, just like we did last time, you want to split this out. So it's going to split into negative 2 and positive 2. You're going to write your negative 2 all the way over here on the left-hand side, and I would set up my positive 2 all the way up over here on the right-hand side. Take whatever's inside of your absolute value symbol and place it in the middle, so x minus 3. And then what you want to do is take your sign. Here it is the less than symbol, so you're just going to write in your less than symbol. So we have two different problems going on here now. We have negative 2 is less than x minus 3, and then we also have x minus 3 is less than 2. So let's work with the left-hand side first. We have negative 2 is less than x minus 3. Add 3 to both sides, and you're going to get 1 is less than x. You notice that the big side of the symbol is facing the x. So when I write x first, the big side of the symbol will still need to be facing x. This says that x is bigger, x is greater than 1. Let's work on the right-hand side now. We've got x minus 3 is less than 2. So x minus 3 is less than 2. Add 3 to both sides to get x is less than 5. Those are my two solutions. And then if we wanted to graph it, we would put it on the number line. We have 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And you would have an open circle here at 1. It's open because we're using the less than symbol and not the less than or equal to symbol. If we use the less than or equal to symbol, we would close the dot in to indicate that it's equal. But here it's not, it's just less than, and over here it's less than 5. Alright, so x is greater than 1, so we're going to shade in area bigger than 1, and x also has to be less than 5, so we're going to shade in an area that's less than 5. Let's write our final answers down. We're going to say that the absolute value of x minus 3 plus 1 was less than 3, and this happened when x was bigger than 1, and it happened when x was smaller than 5. To write it in interval notation, take your two numbers, 1 and 5, and I put parentheses around them because this is less than. If it was less than or equal to, I would use brackets. When we go into set builder notation, you can just write a brace, an x, such that x is greater than 1, x is smaller than 5, and then you can close up the brace.